Welcome to MrCScience.com's video on experiment 1.2 for general science. We're going to do an experiment today on atomic motion. You read about Democritus. One of the things you didn't get right is that atoms are in motion. This is going to show how atoms truly are in motion and how heat adds more motion, causes more energy, makes more motion. Okay, so what we're going to do is we're going to take two beakers. We're going to put about the same amount in each beaker, so I'm going to put about 150 milliliters in each beaker here. Just about. They don't have to be exactly the same, but they should be pretty close to the same. Reduce the number of experimental variables you have. So one of these I'm going to put on and heat it up. There we go. Got that going. Got that going. Excellent. So I got my gloves for later on when I have to take it off. So we're going to heat one up to pretty much boiling. So we're going to get it super hot. The other one I'm going to stick in the fridge here in a second. But let's go ahead and write up your lab. So we're going to write up this lab just like we did the other lab, so you'll get used to the way we do it. So as usual, go ahead and get out your lab notebook or a new sheet of paper or a new sheet on your word processor. Okay, let's start by writing up our lab. So on the top of the lab, first line, Roman numeral number 1, title, colon. Every experiment should have a title, so our title for this one is atomic motion. Okay. And then go to your second line, Roman numeral number 2. Oops. Okay. Roman numeral number 2. What's going on? There we go. Purpose. Every lab should have a purpose. This is to demonstrate how atoms are in motion. Okay, Roman numeral number 3. Next line. Again, if I'm going too fast, pause the video and catch up. Hypothesis. This is our educated guess. We're guessing that hot atoms move more than cold atoms. So hot atoms move more than cold atoms. Okay. Roman numeral number 4, IV period. Materials. Again, an exhaustive list of exactly what we're doing, so if someone wants to repeat this, but again, we're not going to waste that time. So we're going to do as per text. Roman numeral number 5. Procedure. Again, as per text. They can look in our textbook if they want to repeat this experiment. That leaves us with Roman numeral number 6. Observations. This is where we record everything we see and record any data we measure. Okay, so we're ready to start our experiment. If we look over here, we see our water is starting to boil. It's getting hot. So we're going to give it just a hair longer. So I'm going to use the magic of video, and I'm going to pause the video and let it go to get to a decent boil. Oh, I've already put the other beaker in the refrigerator. Okay, we're starting to boil at a decent amount here, so we're going to go forward. I grabbed my beaker out of the fridge. I'm going to put it here on this sheet of white paper so we can see it better. Underneath is a hot plate, so keep everything good. What we're going to do is I'm going to take it off and I'm going to add a drop of food coloring to each beaker, and we're going to observe what happens. So let me put on my oven glove. Here, let's turn off the heat. Grab my oven glove, put that on right there. So turn it so you can see better. There we go. Okay. So I wonder if we can even get it a little bit closer. There we go. Now we're angled. There we go. Okay, there you got a decent view. So let's go ahead. Now here's our hot, here's our cold. Let's put a little drop of food coloring in each. So drop of food coloring in the cold, a drop of food coloring in the hot to add it a little more in the hot, but that's alright. You'll see what's happening. So you can see right away the cold is just going to the bottom. It's sinking down. The hot, look at that, it's already diffused. So in order for the food coloring to diffuse through the liquid, it has to move. And if those atoms in that liquid are moving faster, it will diffuse faster, it will change. So this one already looks like Kool-Aid, although if you drink it, it'll just dye your teeth red. This one's still working. So let's go ahead and record our first observation. So under observations, we're going to say food coloring in cold water went to bottom. Food coloring in hot water diffused throughout the beaker. Not the beaker. Beaker. There we go. Okay, so let's take a look and see how things are going. So yeah, it's still completely red here, and we're still seeing just on the bottom. If I lift this up, you can see all this kind of pooled on the bottom there. There's a little bit going up, and it's going. So what will happen, and we'll give it a little bit of time effect here. Let's give it a few minutes here, and I'll come back to you and we'll see what happened. Okay, it's been about 15 minutes, and we finally have it diffusing through, so it took quite a lot longer. So let's record that under observations. After 15 minutes, the cold water sorry, look, sorry. Or no, we'll say after 15 minutes, the food coloring was diffused evenly throughout the cold water. Okay. So it's a little different color because I actually ended up putting a little bit more in this one, but that really didn't make much of a difference. It still happened really quickly here, and it wasn't because of the extra food coloring. So let's finish our lab. Let's go back and do our conclusion. So as I've said before, and I will say many times again, the most important part of the lab is the conclusion. Why? Because it's worth 50% of your lab, so if you forget to do it, that's half off. In conclusion, kind of restate what happened. We'll just call it dye, diffused through the hot water much faster than the cold water. Okay, so that's kind of what happened. This shows that the atoms in the hot water are moving faster than the atoms in the cold water. Okay, so I kind of restated it, did a little analysis, and let's address our hypothesis. Our hypothesis: hot atoms move more than cold atoms. So our hypothesis was correct. Yay! Okay, again, if you're behind, it's pause the video, catch up. But if you wrote down everything exactly like we did it here, hey, you got 100% on the lab. So if you have any questions at all, drop me a line at mrc@mrcscience.com. Thank you.